Hi then, this is question 4 on page 227. It's working towards grade A, but not quite yet. So question 4 then, it says in this diagram, AB equals DE, so AB and DE the same. CD is 4, there it is there, and CE is 9, and there it is there. It says find the lengths BC and AC. Yeah, that's it. So I want this one and this one. Well, I can see the answer straight away, probably you can as well. I feel I have to prove that these two triangles are in fact congruent. If I can't prove that, I can't be sure of what BC and AC are as lengths. But let's look at it very carefully, since we're talking about congruent shapes or congruent triangles. Now look, we have a corresponding angle of 30 and 30 in each triangle. Alright? We have one corresponding length that's given to us. I can't guarantee that this 4 is that 4 yet. I can't. I need something more. And I found it. This angle here is identical to that angle there because they're vertically opposite. So let me just state that. And this is going further than the question requires, but you need to understand why I'm going down this route. So let me just state it. Angle BCA equals angle DCE. In other words, they're the same. And I put in brackets my reasoning. Vertically opposite angles. So I've established I've got an angle there that matches the 30, an angle here that matches this angle here. Now look, if this angle is 30 and this red angle is whatever, what's left over must belong to angle B and angle D, and they must be the same as well. If I've got two angles in a triangle that are the same as the other two angles in the other triangle, then their third angle must be the same as well. Now I'm going to show that by putting a little blue arc here. So this B angle and this D angle is the same. Now let me just state that in a different way. So ABC, so angle ABC equals angle CDE. CDE. C. I would have stated this wrongly. This should be DCE. Let me just change that round. I was thinking too far ahead. That's angle DCE. So forgive me. Let's check again. BCA, DCE. Okay, the two reds and the two blues. Check the blues again. ABC or ABE is the same as CDE. Yep, happy with that. Why is that? Because angles in a right angle, angles in a triangle add up to 180 degrees. Is that alright? So where do I get the blue angles from? Well, angles in a triangle add up to 180. Therefore, if I've established that the two vertically opposite angles are the same, then the remaining angle, the B and the D angle, will be the same. So what have I got here? Very clever. Look at this. Let's work in yellow. I've got an angle, 30. I've got a side, and I've got another angle here, which I'm going to call B. Is that alright? So the B angle and the side and the 30, the A angle. So I've got angle, side, angle. Do I have the same over here? Yes, I do. Look, I've got the D angle, same as the B angle. I've got an angle, side, look, corresponding side with that yellow one opposite, and I've got the angle of 30 again. And here it is. So essentially I've proved using congruences that these two triangles are identical. They are congruent. Look, angle, side, angle. Angle, side, angle. Blue, side, 30. Blue, side and 30 degree angle there. Therefore they're congruent. I'm going to state that. So A, B, C and D, C, E, and these of course triangles, aren't they? So you have the symbol triangle. These two triangles are congruent, and the rule is going to be ASA. Now I've established that they're congruent. It doesn't ask me for this because anyone can come along and guess that in fact CB is going to be 4 and AC is going to be 9. That's exactly what they are. So I've got it then. BC is going to be 4, because it matches that 4 there, and CE is going to be the same as CA because that matches that side there, they're corresponding. So there we go. So that's it, proven, dead easy. And that's that. So question 5, I think. Bam. Now these are grade A. There's no numbers, there's only letters. This is question 5. It says prove that each of the following diagrams contains a pair of congruent triangles. Okay, well let's have a look then. So in other words, is ACB, is this one identical to CDE? That one. I'll try and prove it. Let's have a look. I can see that AB is identical to DE because they are of the same length. Look, I was given a line and a line, so let's just state it straight away. So AB equals DE. I'm on my way. Now look, if these are parallel lines, then this angle here, say, will be identical to that angle there, because look, they're vertically opposite. Okay, so it's a straight line, 2 parallel lines, and these angles are vertically opposite. So let me just state that. So angle ABC equals angle CDE. Why? Because they're corresponding angles. So what about this one here? Well, look at it again. This angle here, the A angle, is also corresponding to that angle right there. What have I got? Straight line, parallel straight line. Therefore this angle is identical to that angle there. The A angle and the E angle are the same angles. So let me state it. BAC, so angle BAC equals angle DEC. Angle DEC. Why is that? They're also, sorry, not corresponding, these are alternate angles. Oh, alternate angles. Let me just change that. They not correspond. They correspond to each other in terms of their position, but it's on the other side of the line. So I have to call them by the correct name here. They're alternate angles. In blue, please. Here we go. Alternate angles. So here we go. So this blue angle here, the B angle, is alternate to the D angle there, and this red A angle is alternate to the other red E angle. So what have I got at the moment? Well, if I stop and pause for a moment, I've got angle, side, angle. Okay, red and side and blue. So angle, side, angle, angle, side, angle, and I therefore I've proved that they're congruent. So triangle CAB is congruent to triangle rather. Might need to take a nap in it, I'm getting tired. Is congruent to triangle CDE because of the ASA rule. Is that okay? ASA rule. Now what about this? This looks quite easy, I think. Yes, really easy. Now look, I've got this side corresponding to that side and they're identical. I've got this side corresponding to that side and they're identical. Now look at this. The angle formed at H on this side is identical to the angle formed at H on this side because they're vertically opposite angles. So let me just state it. Angle FHG equals angle IHJ, why? Vertically opposite angles. So what? Well look, I've got a side, angle, side triangle. Side, angle, side triangle. So they're congruent because triangle FHG and triangle IHJ show the SAS rule, side, angle, side rule. And that's all there is to say about that. Now what about this then? let's just take a good look. Well, this is it looks like the RHS rule, doesn't it? Look, right angle. The trouble is we're not told that the two opposite sides, the hypotenuses, are exactly the same. Now they have to be, because look, they each have two lengths the same, which means that the third length has got to be the same. But I won't even go by that. We're told that Km equals Mn, and we're told that ML equals MP. So straight away I've got two corresponding sides that match exactly. And look, the angle between these sides is a 90-degree angle. It doesn't have to be 90 degrees, it just happens to be 90 degrees. But if whatever the angle is on this side, they're vertically opposite to each other, and therefore they're the same. Therefore I've got I've got a side, angle, side rule. There it is again. Side, angle, side rule. And let's just state it. Let's state the obvious. Km equals Nm in terms of length, and I've got ML equals MP, and I've got angle KML, that one, is equal to angle NMP, therefore congruent, because of the side angle side rule, SAS rule. Okay, side angle side, and they correspond and they match perfectly. So I'm going to stop there. That's quite tricky, and there's two more questions before we do the assess, and then it's end of topic.